Okay, we made it to part C of the test. Let's get this done. Question 66 and 67. We need to calculate the magnitude of the gravitational force acting on this oil drop. Perhaps I should actually read the problem. The diagram shows a negatively charged oil drop that's suspended motionless between two oppositely charged parallel plates. The electric field strength between the plates is 4 times 10 to the fourth Newton per Coulomb. The 1.96 times 10 to the negative 15 kilogram oil drop is acted upon a gravitational force, Fg, and electrostatic force, Fe. We want to calculate the magnitude of the gravitational force in question 66, 67, or Fg. Let's head to the reference table. Since we're looking for an Fg, my eyes automatically dart to gravity and weight. Fg for comparing two objects. We don't have two objects this time. We just have the one object, so I can just use this particular equation. G is Fg divided by m. I always cross multiply when I write this, so this is F of G is mass times gravity. I like my equations written that way. Others may differ. Fg is what I'm searching for. My mass of this particular oil drop is 1.96 times 10 to the negative 15 kilograms. What's G? Well, that's gravity, 9.81 meters per second squared. So the Fg, or the weight of this oil drop, the force of gravity acting on this oil drop, is 1.92 times 10 to the negative 14th newtons. Question 68. Determine the magnitude of the upward electrical force. Well, if gravity is trying to take this drop and pull it down, the force of gravity, or the weight, is trying to pull it down, and if it's suspended, then this oil drop has to have an equal but opposite force causing it not to do that. This is the electrostatic force in this case. This is equal. These are equal to each other. So all I'm going to do is write 1.92 times 10 to the negative 14. Oh, wow, they actually gave me the unit there in their box. Question 69 to 70. Now they want us to calculate the electric charge on the oil drop in coulombs. Well, the problem tells me that the electric field strength is 4 times 10 to the fourth Newton per Coulomb, and I know that the electrostatic force is 1.92 times 10 to the negative 14 newtons. I'm looking for the charge on the object, which means I need an equation with an E, an F, and a Q. Let's head over to the reference table. Since we're talking about electrically charged plates, it makes sense to go to electricity. And sure enough, there it is. E is F over Q. E is the electric field strength. F is the electrostatic force, and Q is the charge. So they tell you the words, you just got to look up what those letters are in case if you forget. So E is equal to F over Q. My electric field strength is 4 times 10 to the fourth Newton per Coulomb. Fe was 1.92 times 10 to the negative 14th newtons. And Q is what I'm searching for. These two items just swap spots, and you'll end up with a Q equivalent of 4.8 times 10 to the negative 19th coulombs. Base your answers to questions 71 to 75 on the information below. We have a circuit, and in that circuit we have a 100 ohm resistor and a 200 ohm resistor, and they're connected in parallel to a 10 volt battery. We need to first calculate the equivalent resistance of the circuit. Let's head over to our reference table to remind ourselves what equation deals with equivalent resistance of a parallel circuit. And here we are at parallel circuits and how to find the equivalent resistance. As you add more resistors, the overall resistance goes down. Let's calculate it. Don't forget to take the inverse of your answer. You'll end up with Req of being 66.7 ohms. A good way to check yourself so you don't wreck yourself is your overall resistance of a parallel circuit is always less than the smallest resistor. And yes, smallest resistor is 100. I'm under 100. Oh yeah. Question 73 to 74. Calculate the current in the 200 ohm resistor. I want to know what's the current flowing down that 200 ohm resistor. So since I'm only looking at that one particular branch, I can use V as I times R, or Ohm's law. The voltage here is 10 volts. The current down that branch is what I'm looking for, and that current is dependent on the resistor in the branch, which is 200 ohms. This gives us a current of 0.05 amps. Question 75. Determine the power dissipated by the 100 ohm resistor. So I need to use my power formula for this. And in this particular case, I know that it's the 100 ohm resistor, and I'm in a parallel circuit, so my voltage is 10. Many different formulas for power. Let's take a look at what we need to use. So here we are. We're looking for the amount of power in the 100 ohm resistor. I know my resistor and I know my voltage, so from there I can solve for my power going down that particular branch, or P is V squared over R. And you'll end up with a power of 1 watt. It's the final countdown now. Only one page to go. Click ahead to page 15 or retry 13. Let's get it.